Hi, Geometry. Yes, I'm sitting here listening to your playlist again. I can just picture you dancing in the classroom because we just love that Never Gonna Give You Up. Well, let's start talking about areas of circles and sectors. We're going to start with the area formula for a circle. So hopefully you remember that the area of a circle is pi r squared. So you can only use the radius, you square it, and then multiply by pi. All right, so here's an example where it says find the exact area of the circle and then find the area to the nearest hundredth. Well, exact means leave it in terms of pi. Okay? So if I'm going to do it exactly, I'm going to say the area equals pi times 5 3/4 squared. Okay. Now I changed it to an improper. A little faster here. I changed it to an improper fraction. So you get pi 5 times 4, 20, 23/4. And then you're going to square that. When you square it, you get 529 pi, or 529/16 pi, and you can say inches squared. That's your exact. Now where it says round to the nearest hundredth, we'll actually do this. 529 divided by 16 times pi, and you should get 138.87 square inches. So exact and rounded to the nearest hundredth. All right, so let's talk about sectors. A sector is the part of the circle bounded by two radii and the intercepted arc. So if I look down here at this picture, APB is the sector. So this little orange shaded piece. Think of it like a piece of pizza if you're going to find the area. I'm going to show you one where it's a cookie. Okay, so you're looking for the area of that slice. If you're home and you've been playing games with your family, maybe you've been playing Trivial Pursuit. It's like one of those pieces in the wedge. So let's go see what this looks like. So this is on GeoGebra, and I'll put it in Classroom so you can play with it. So here's our cookie, and we see that we have the area of the whole thing, and when we want to find the area of that piece, like that piece of the cookie, so that's 1/8. You're going to compare, so just like we did with the circumference, you're going to compare the angle measure to all the angles, right? So the total sum of the angles. And your other part of the proportion is going to be the area of this piece over the total area of the, in this case, the cookie, but of the circle. So we're going to be setting up a proportion once again. Let's see what that looks like. Okay, you need to write this down. The area of a sector. So the area of the sector of this sector APB, so that piece compared to the area of the whole thing, pi r squared, is going to be equal to the measure of the arc measure, so the degrees, over 360. So this part of the proportion is not different from what we did for circumference. It's this part that's different in that we're comparing areas instead of the sector. Now, you could also think of it as that the area of sector APB equals the measure of the arc AB over 360 times pi r squared. Okay, however you prefer to look at it. Okay, so this one says find the areas of the sectors formed by that angle ACB. So the small and large sector. So the small one is the shaded part here. And then we have our unshaded would be the big one. So let's start with the shaded part. Okay. Well, I can see, right, I'm looking for the area of the sector ACB, and I'm going to compare it to the area of the whole thing, and I can see that the radius is 8. On this side, I'm going to have my degrees 60 over 360. All right, so this here simplifies to 64 pi. So the area is going to be 60 divided by 360 times 64 pi. Okay. When I do that, or when you do that, what you should get is 33.51 square inches. Now, for the unshaded, I could either set up another ratio, or I can find the area of the whole thing and subtract this. All right, so I'm going to go that way. So the total, the area of the whole thing, we just found out was 64 pi. And we're going to take away from that 33.51. Okay, so I haven't done this out yet. So you do it too. I get this part here, 64 pi is 201.06. So I'm going to take away the 33.51. And I'm going to get 167.55 square inches. Okay, so again, you could do it one of two ways. All right, now we're going back to our area formula. So the area of a circle is 225 pi, find the radius. Okay, so if my area, 225 pi, equals pi r squared. Well, I like this because when I divide by pi, pi's go away. So I get 225 equals r squared. Hopefully you recognize that as one of our perfect squares. When I take the square root of both sides, I get 15. All right, that was good. For this one, the area of a circle is 390 square meters. All right, so 390 equals pi r squared. It's asking me to find the diameter. So, well, first I'm going to solve for r. Divided by pi, and I get 124.14 equals r squared. Take the square root of both sides, and you get your radius is approximately 11.14 meters, but it asked me for the diameter, so double it, and you get 22.28 meters. Well done. Let's move along. Okay, if you want to try these on your own and then come back and check, you can. I'm going to work through them myself. The first thing I did is I read it, and I said, okay, the total area is 624.36. And then I labeled the vector, or sector, not the vector, but there is a thing as a vector. We won't go there though. All right, 64.17 meters. Find the radius of the circle. All right, well, I know that the total area is 624.36. Okay, so I'm going to divide by pi, take the square root, and I get the radius is about 14.1 meters. To find the circumference, well, I have that radius, so 2 times pi times 14.1, and I get 88.58 meters. Okay, the measure of arc ST. So I'm going to put this one down here. Okay, so I know the area of the sector is 64.17. And I know the area of the whole thing is 624.36. And I'm going to compare that x over 360. Okay, because I'm finding, I can use that to, because I'm trying to find the angle measure of the arc. Cross multiply. And what do you get? You should get 37 degrees. So put that here. For number 8, I'm going to use what I just found. I'm going to say 37 over 360. This is actually the second half. So I just flip-flopped my ratio, but it's okay. Equals x. All right, in this one I used, because I'm looking for the circumference. 2 times pi times 14.10. Or I could use this because I had already found it. Cross multiply, and you should get it's about 9.1 inches. All right, because I'm looking for the actual length of that. Okay, so now that I have that, the perimeter of the shaded region, so I'm going to do SV plus VT plus ST. So I have two radii. Right? So I'm going to do 2 times 14.1 plus, we found the measure of that arc is 9.1. And you should get 37.3 inches. So the perimeter of the unshaded region, well, I can take the total circumference, right? 88.58, and subtract from that the 9.1. Right? And I get 79.48. Lots of good math going on here. All right, so hopefully you caught all of that. Now this one I like. See, I like this picture. Every time I look at this picture, it always reminds me of like a little gnome peeking over, like, I think of those things like hanging off a flower plant, but just those little eyes poking out at us. That's what it looks like to me. But what we have to do is find the area of the shaded region. Okay, so I have that it's a semicircle, right? So if I found that the 2 centimeters is the diameter of the unshaded, so this would also be 2 centimeters. So the whole, so the shaded and unshaded would be 1/2, right? It's half a circle of pi times the radius of the whole thing would be 4. Right? So I get half of 16. Okay. Now, maybe you notice that if I put these two unshaded, it's one whole circle. Okay, so if I wanted to find the unshaded, right, because I'm going to subtract that from the whole thing, the unshaded piece would be pi times 2 squared, which is 4 pi. What do you know? It's half of that whole thing. So I do 8 pi minus 4 pi. The area of the shaded region is 4 pi centimeters squared because it's area. All right, nice job. I will talk to you soon. Keep up the good work.